Kia ora koutou, nau mai haere mai, and thanks so much for being here. Christine Harper has left Manaaki Whenua for a well-deserved retirement, and I joined about a month ago as an engagement advisor. Today, we're really pleased to be providing you with an overview of some research that's happening across the country that's giving us more information on use of diverse pastures as a mitigation practice for reducing nitrogen losses to our waterways. As part of a 4-year Ministry for Primary Industries funded SLMAC, Sustainable Land Management and Climate Change project, this one is Freshwater Mitigation Program. A group of our researchers and technicians have been studying the nitrate leaching losses from diverse pastures across New Zealand with different soil types and different management systems and techniques. Scott Graham is here to present to us today. He's a senior research and data analyst with Manaaki Whenua, and he's presenting these findings today as part of a wrap-up of that 4-year project. So welcome, Scott. We're really looking forward to hearing from you. Thank you.
Tēnā koutou. Thanks, Joe, and thanks to everyone for attending. Yeah, I really wanted to acknowledge the wider team that's involved in this work on diverse pasture leaching losses across a number of our sites here at Manaaki Whenua. So the context of this work, most people will be familiar with, is that leaching of nutrients, primarily nitrogen, from our livestock agriculture is a risk to surface and groundwater. You can see on the map here of spatial nitrogen leaching rates for the entire country. Canterbury and Waikato figure very heavily in this map, and that's probably not a surprise, as these are hotspots of our more intensive agricultural practices, mainly associated with dairying. And as a result of these this risk to water quality, there are national and regional regulations for reduced nitrogen leaching. It's not just regulators that are interested in reducing losses. We also have farmer-led catchment groups that are also interested in finding solutions to minimize the environmental footprint of farming, as well as for the sake of agricultural efficiency. It's when we lose nutrients out the bottom of these systems, it's a waste of what could be valuable nutrients, otherwise valuable nutrients. So use of more diverse pastures has been suggested as a potential mitigation option, but this is largely unverified with long-term field studies. So stepping back a moment, what do we mean by diverse pastures? Well, in the ecological literature, it's generally been established that there's a positive relationship between species diversity and ecosystem function. In this case, the function of interest would be soil nitrogen retention. And across New Zealand, the commonly used pasture type is a 2-species mix of grass legume mix of perennial ryegrass and white clover. That's common throughout the country, but increasingly common are more diverse mixes of grasses, legumes, and other forbs that include a suite of functional traits, including increased winter activity, more nitrogen fixers, deeper rooted species, and then species such as plantain that can have an effect on microbial transformations of nitrogen in the soil and thus retain more nitrogen. And these are so-called biological nitrification inhibitors. So how do we measure leaching losses? For the purposes of this study, we used lysimeters, and these lysimeters produce a direct measurement of leachate from an enclosed volume of soil. You see here in the photo, a set of our large lysimeters at the Ashley Dean Research and Development Station under construction. And here's what it looked like under a full crop of lucerne. You can no longer see the lysimeters. Many of you may be more familiar with these arrays of smaller lysimeters of 50 centimeter diameter lysimeters that are well replicated. But we here at Manaaki Whenua have opted for larger lysimeters, the advantages being that you integrate a much larger volume of soil and the heterogeneity within. You can accommodate deeper rooting species and measure their benefits. And you can also represent the spatial variability of inputs, particularly from animals in their sort of representative patch sizes and amounts. And then we can embed these arrays within paddocks, receiving paddock scale management, such as fertilizer input, effluent inputs, and irrigation. The limitations are that we still tend to fence these sites off, so it's very difficult to look at animal-mediated effects, such as changes to the amounts or concentrations of animal inputs from a given diet. We still have to simulate grazing. And then because these are large and costly installations, our replication is typically low. Manaaki Whenua has a network of these large lysimeters. The first site that we used in this project and converted to diverse pasture is at the Ashley Dean Research and Development Station here down the road from us in Lincoln in Canterbury. And it's in an effluent irrigated portion of the farm, which is representative of high intensity dairy common in the area. We've got 6 lysimeters in this area, 3 of which we converted to the traditional ryegrass clover, and 3 more we converted to a 5 species diverse pasture mix. On a slightly less intensive portion of the farm, which receives irrigation only, we planted another 3 large lysimeters in diverse pasture. And then on a low intensity, non-irrigated portion of the farm, we have another 6 large lysimeters that we planted in diverse pasture. And you can see here the differences in the inputs from 25 to 130 kilograms of nitrogen per hectare per year at the non-irrigated site, all the way up to 500 kilograms of nitrogen per hectare per year at our most intensive site. So these broadly represent a gradient in management intensity. And you might be looking at those inputs and thinking, how does this relate to that 190 kilogram per hectare per year cap on fertilizer use? But these inputs include fertilizer, nitrogen from effluent, and also the simulated animal excreta, which we estimated as appropriate to the estimated production of each site. So that's Ashley Dean. We have another lysimeter site in Tihoi in the Lake Taupo catchment on the North Island, and we have 20 non-irrigated lysimeters there, 8 of which we converted to ryegrass clover, and then with 12, another 12 converted to a diverse pasture. This is a non-irrigated site, but it receives 1,300 to 1,600 millimeters of rain, which is about twice that we get here in Canterbury. So a strong kind of climate contrast between the 2 sites. Another important contrast being that Ashley Dean has these very stony soils with up to 70% stone content in the subsoil, while Tihoi has a deep volcanic pumice soil that's relatively stone-free. So we have this strong contrast between the 2 sites in both the soil and the climate. So in addition to our management contrast that we have at Ashley Dean. So if we're looking at a mitigation practice, the first metric that will be of interest to us is, of course, dry matter production. We don't want to use a practice that's going to produce less feed for animals. So what we had as part of this project is 3 full years of measurement. And across these 3 years, what we saw as far as dry matter production at our site was the irrigated effluent site at Ashley Dean producing 10.5 to 13.5 tons per hectare per year. The irrigated only site producing 3.5 to 11.5 tons. The non-irrigated site producing 1 to 6 tons per hectare per year. And then Tihoe producing 7.5 to 15 tons. As far as the difference between ryegrass clover and diverse pasture, some of these low numbers, I should point out, are due to poor establishment at some of the sites, particularly our lower intensity sites at Ashley Dean. We had poor establishment in the first year, and then at our non-irrigated site at Ashley Dean, these establishment issues actually persisted into the second season. As far as the difference between the pasture types, they were relatively few, with the exception that we did see a 27% increase in production by diverse pasture relative to ryegrass clover in year 2 at the Ashley Dean site, effluent irrigated Ashley Dean site. But when you looked at production by that site across the cumulative production for the 3 years, the difference became non-significant. So relatively few differences in production by the 2 pasture types across our sites. We did see this strong increase in production across our management intensity gradient at Ashley Dean, and that's expected. That's good. That's why we do these more intensive activities. And then as far as our diverse pasture goes, the species and functional group representation was highly variable through time as well as across sites, with plantain tending, which is included in all mixes, dropping out relatively quickly.
Okay.
So in addition to soil drainage, to production, soil drainage is another important driver of soil drainage is another important driver of nitrogen leaching. So as far as drainage goes, this figure here shows these curves show accumulated drainage throughout the leaching season, which we set as October through September of each year. So at the end of each year, the drainage volume is reset. So at the Ashley Dean irrigated and effluent site, what we saw was 170 to 330 millimeters of drainage across annual drainage. And the only time that we saw a difference between the diverse pasture in blue and ryegrass clover in red was in year 2, when diverse pasture drained 29% less than the ryegrass clover. At our less intensive irrigated only site, drainage amounts were similar, 225 to 345 millimeters. And then at our non-irrigated site, again, a reasonably similar volume, 180 to 310, indicating the strong sort of winter drainage period. Although we did see some instances at our irrigated sites where soil drainage in spring and summer was triggered by irrigation. So this is something that shows us where we can improve management to reduce these these spring and summer drainage events, which past work has shown can lead to high nitrogen losses. We could use better management to minimize these spring and summer events that didn't occur at our non-irrigated sites. You're probably wondering what these gold shaded regions are. These are time periods at Ashley Dean when the groundwater was exceptionally high and came up above the level of our measurement tippers, where we measure the drainage volume and collect leachates. During these periods, we couldn't actually measure drainage or leaching losses. But we don't think this led to any, we don't think this compromised our findings, as we can see from sites that were operating during the time period that there were very few drainage events that we missed. So this photo just shows our flooded caisson where we collect leachates. And one interesting thing to note is that we sampled water across our different sites at Ashley Dean that had come up from the ground into these caissons, and the nitrate concentration of the water was about 10.5 milligrams per liter across these sites. And that's a bit concerning because it's very close to the human health threshold of 11.3 milligrams per liter. Now that's water that's not water flowing into the pit, that's water coming up from below, so it's shallow groundwater. Just a point of interest. So moving on to drainage at the Tihoe site, that site receives about twice as much water input, and as a result you get twice or more as much the drainage volume, but again no difference in pasture type. And you should also note the progressively wetter years that we had. In 2021 we had a dry summer followed by a moderate winter leaching season, whereas in 21-22 we had a relatively dry summer followed by a wet winter, and then in 22-23 we had leaching throughout the year, or drainage throughout the year. So how did this translate to nitrogen leaching? Well, this is our, again, our Ashley Dean irrigated and effluent site, which we converted in April 2020 to diverse and ryegrass clover pastures. And immediately following that conversion, we saw very high losses of more than 120 kilograms of nitrogen per hectare over the course of that leaching year. These are higher losses than we'd seen in any previous or subsequent year of measurement. And that was a response to the autumn conversion and the pasture not having enough time to establish before the leaching season started. So the leaching season commencing before we had complete cover really led to these high losses. So it kind of shows that timing of these conversion activities can be very important for leaching losses. For the subsequent measurement years of diverse pasture, the losses were 27 to 80 kilograms of nitrogen per hectare per year. And one thing to notice is these arrows on the graph represent the timing of simulated inputs from animal excreta. So we were adding nitrogen appropriate to the management system throughout the time series. And again, similar to both the production and the drainage, we only saw significant impacts in year 2 of the different pasture types, where losses were 2.8 times higher from ryegrass clover than diverse. So diverse pasture had higher production, lower drainage, and lower leaching losses in year 2. But over the whole record, again, these when you looked at the accumulation of 3 years, these effects became insignificant. At our irrigated only site, a less intensive system and we had lower nitrogen losses, 3 to 26 kilograms of nitrogen per hectare per year. And then at our non-irrigated site, despite the lower inputs, we actually had higher nitrogen losses. But again, some of these losses were related to the conversion. We had a pulse of nitrogen coming early on from our irrigated only site, which was established in October 2020. And so we had these conversion related losses. And then again at our non-irrigated site, where we had 2 subsequent years of poor establishment, we had these persistent high nitrogen losses. So again, pointing to the fact that timing and success of these conversion activities can affect leaching losses. At our Tihoe site, where we established diverse and ryegrass clover pastures in October 2020, we had very low losses in the first year, so we didn't see these any pulse of nitrogen following conversion, but that was probably related to the good establishment as well as a reasonably dry summer following the conversion. At Tihoe, losses were 2 to 98 kilograms of nitrogen per hectare per year, with no difference in pasture type. So with regard to this 98 kilograms of nitrogen per hectare, that's very high considering the sort of Lake Taupo region level of intensity. And that's because these are not paddock scale losses. When we applied urine to these simulated urine patches to these lysimeters, they're smaller than the they're smaller diameter than the Ashley Dean lysimeters, so we could only apply 1 urine patch to the whole lysimeter. So these represent the losses of just a urine patch. And if we wanted to scale to the paddock scale, we'd have to reduce these with the consideration that the rest of the paddock wouldn't have received nitrogen and losses would be low. So in general, you could, an estimation is that 25% of the paddock is covered by urine patches at the end of a given year. So you could scale these numbers as such. So in conclusion, annual leaching losses from diverse paddock scale leaching losses were 2 to 80 kilograms of nitrogen per hectare per year, depending on plant production, volume and timing of drainage, quantity and timing of nitrogen inputs, and timing of conversion activities. Harvested dry matter, drainage volume, and leaching losses from diverse pasture were not different from ryegrass clover pasture. Although I just have to note again that any changes to animal inputs because of their diet are not considered in this study. We added the same amount of nitrogen to all of the lysimeters regardless of pasture type. This isn't the final word on the use of species diversity to improve ecosystem function. More work is needed on pathways to maintaining higher species and functional diversity. As I said, we had very high variability across years and sites in our species representation of diverse pasture. So in order to get the benefits of diverse pasture, we may need to follow 2 possible pathways, one being management intervention. For instance, oversowing of plantain has been suggested to maintain a high plantain content in swards and to get the maximum benefit of that species. And then on more the track generally associated with regenerative agriculture, we can plant these highly diverse species mixes where where there can be multiple species that can fill a given functional role. So loss of any success or failure of any given species is potentially less important. And here at Manaaki Whenua, we're doing quite a lot of work in this area. We've just recently installed a set of 2 sets of lysimeters, one on a conventional and one on a regenerative farm as part of the Sustainable Food and Fiber Futures project, Te Whenua Ho project, led by Naitahu Farms. And we'll be continuing to look at that, at leaching losses from that site. Although we didn't see an effect of more diverse pasture in the case of this project, we did generate a valuable data set, and process-based modeling using our data will make it more generalizable for use by decision makers and other decision support tools such as Overseer. And then in this case, we've only looked at leaching losses, but we always need to consider additional co-benefits and trade-offs of any mitigation practice. For instance, here at Manaaki Whenua, we've demonstrated that you can have reduced nitrous oxide losses from diverse pastures, but when you look at their net greenhouse gas emission, it's great. It's less favorable than traditional ryegrass clover when you consider CO2 losses from the different systems, so there can be trade-offs. And just ending on a few recommendations for reducing leaching losses. Although we'd like to say diverse pasture would reduce losses, we can't from the current study, but what we can say is that if you manage irrigation, you should manage irrigation to minimize drainage events that are occurring during the growing season. And the timing of management activities such as cultivation and renewal should be done to ensure full pasture cover before the drainage season begins. And we also showed that intensive activities such as irrigation can facilitate establishment and reduce losses, but oftentimes the result of these more intensive practices is more grazing and more inputs from animals, which can lead to more losses. So thanks for your attention. As Joanne said, this was a MPI SLIMAC project, and we'd like to thank Ashley Dean, Research and Development Station, and the Tihoi landowners for allowing us use of the site. Thank you.
Kia ora, ngā mihi nui. Thank you, Scott. Look, we don't have that much time for questions. To assure people that the questions that have already been put in the chat will be answered, we'll send them to the research team and they'll get onto them, and that will be uploaded to our website as always. Perhaps I can just ask one very, very simple question in the time we have available to us. I'm not a scientist, it's not my background. And I just want to confirm, drainage season refers to the rainy season, right? It refers to when there's going to be a lot of rain coming up.
Yep. That's as I said in Canterbury, we have a strong winter drainage season. That's when we see the majority of the drainage events triggered by winter rainfall, and also less crop growth and evapotranspiration as a alternative pathway for water to leave the system.
Okay, perfect. And just one more question before it ticks over to 11:31. Poor establishment. Someone's asked a question about the sites in Ashley Dean in the first year. You talked to the fact that they were poorly established. What does that mean exactly?
It just means that when we planted those, it was followed by a very dry period, and the grass didn't grow, didn't survive. We tried to supplement with a bit of irrigation, but it didn't work, so we resowed again the second year. We also had some damage associated with spray drift from a adjacent site. So just failure of the cover to establish properly on the lysimeters. Yep.
That makes perfect sense. Thank you. As someone from a non-rural, non-farming background, these things are really helpful for me to understand. So look, thanks everyone so much. We, as I say, we will post the questions on our website, and you will see an invite in your inboxes very soon for our next webinar, where we hope you can join us. Kia ora koutou. Mā te wā. Thank you.